Welcome to our workshop on the Interact Northwest Europe project RIGHTWEIGHT. And first of all, I would like to give you a short introduction into the project and the goals. Next, and I think most important for today, the challenges we have. And after that, we will give a short overview about the infrastructure and expertise funding scheme. And after our presentations, we will have a business lunch, which is a bit more open in another solution. It's called Wonder. I already posted the link into the chat, but my colleague Matthias Grosch will do this again when it's time to change the meetings. But first of all, let's start with the introduction of RIGHTWEIGHT. Okay, the Interact Northwest Europe program is it supports project that can deliver concrete results to improve the quality of life of citizens and reduce disparities within the regions. There are three main pillars. It's innovation, helping enterprises to innovate. This is our pillar. Then we have low carbon. This is also interesting for us, supporting this shift towards a low carbon economy. And we have the resource and materials efficiency, new ways to produce innovative materials. And now, our proposed solution in RIGHTWEIGHT is to enhance the cooperation between auto and aero industries for reaching environmental and affordable targets. So Aero knows how to truly exploit the potential of advanced materials with improved lightweight performance on a very high level, while auto is leading in advanced manufacturing and affordable mass production. So I think both have very high requirements on the one hand, and on the other hand, they are specialized in a certain way. We have the opinion that components in Aero need to be produced at lower costs at the one side and in higher speeds, and auto components need to be lighter to reduce carbon, for example. So the main objective is to increase the competitiveness of auto and aero SMEs. It's about to deliver new lightweight solutions that meet environmental and affordable targets, support auto and aero SMEs for improving their lightweight products and technologies, and meet car aircraft makers' needs, and to set up a transnational ecosystem that connects stakeholders from both industries to boost cross-sectorial transfer and knowledge. Now, how would we like to do this? Now, first of all, we have this challenge-driven competition. So we have international enterprises who provided challenge-driven competitions to us, thematic challenges proposed by end users and large suppliers from automotive and aerospace sectors. And now the small and medium enterprises can apply with a solution, an innovative solution. The next activity is our field labs and trainings. So we provide the possibility to present the solutions and to these challenges in a competitive approach. And specialized field labs are set up to support the technical development of the winning solutions. So there will be a jury and which will award the solutions provided. And then next, we will have a one-stop interface and knowledge transfer, which will be done online in a tool provided by us, NMWP. So, and I think this is RIGHTWEIGHT in a nutshell. So we have two very dependent on lightweight industries, which should benefit from each other from the solution they developed. And I think before we come to the challenges, we would like to introduce the kit on the one hand and NMWP.NRW on the other hand. So now I would like to hand over to the presentation of Markus Bardinger, who will present the kit and give a short overview about the state of the art of lightweight constructions. Is that right? I think so.
Yes, it is. Thank
Okay,
you, Henrik.
perfect.
Very good. So yes, I'm also a part of the RIGHTWEIGHT consortium. I also initiated parts of the project back when we met first in Brussels 2 years ago, I think almost. And now I want to start with a short presentation on the KIT, especially on the IPEC. So this is my institute where I'm working at. So my name is Bardinger, as Henrik already introduced me, and I'm chief engineer here at the IPEC, and I'm responsible for the CAE optimization group as well as for the development methods and management group. So I'm trying to share my screen, should be possible, I think.
Yes, it works.
Okay, perfect. So
this is the wrong screen. Now we see the presentation. Oh, perfect. Sorry.
Well, as always, thank you. So I want to motivate how we see lightweight design and why I think it is necessary to think about lightweight design in the way we do. So the topic is system-oriented lightweight design. Why system-oriented lightweight design? The idea behind is that we need a holistic engineering approach, which is overcoming the boundaries of different components we're looking at. And this is also possible by methodological approaches, and of course, including the methodologies and tools we know, so such as topology optimization, other optimization techniques as well, into a broader approach. So I will just quickly shortly introduce the IPEC itself. So we are an institute with around about 100 researchers and staff. We have 2 professors. We are structured into different research groups and research fields. So today, of course, the central one I'm talking about is lightweight design. So here on the right side, you can also see our staff, our team, and our different sites we are located on. Furthermore, I want to introduce the KIT Lightweight Design Network. Maybe some of you already know the KIT Lightweight Design Network. So in this network are different institutes, so such as the IPEC. So we are in this network, but also for the production system, for example, the material scientists are also organized in this network. And so we are bringing together our competencies in the 3 fields of methods, materials, and process together to develop new lightweight design solutions. So, but why is still today, or especially today, lightweight design that important? So I brought here some numbers. So I updated it this morning again, so to look into the numbers of 2020. So 2021 is not available yet, but I think it's pretty impressive that over the last 60 years, we doubled the mass of our vehicles, and we also increased the power of our vehicles by a factor of 4. And I think looking at the higher mass shows us that it is necessary to be more efficient, even in the future, that we have to find new lightweight design solutions, especially for battery-driven vehicles, so like BEV or also plug-in hybrid vehicles. And we need to find solutions for the higher masses of our batteries that we have to carry around with us in our vehicles today. So I think also an important part of this development here is caused by the fact that we need to include batteries into our vehicles today. So those are, of course, numbers from the automotive industry, but this also applies in many cases for the aeronautic industries. Of course, today we are thinking about having batteries in airplanes as well. We need to find solutions then to minimize the weight of our aircraft as well. And this also, I think, is the same reason for lightweight design approaches, as we can see it all over. So here just one example, of course, of the projects we worked in the past. So of course, we need new structural materials as they had been included in battery electric vehicles like the i8 from BMW, but as well the i3, for example. But this is also just then possible if you include new construction and design methods, so that you have engineers that are able to apply those new materials to their specific use cases and to fulfill specific functions. So that means from our point of view, lightweight design influences all activities in the design process. So it's not just about replacing material. It's not just about having a new manufacturing process. It's all about having the right engineering process behind it to be able to exploit the full potential of lightweight design. Another example we worked on, and I want to use it to emphasize the different lightweight strategies that are well known, I think, out there to develop new vehicle generations. So I'm talking about product generations here in my talk, my short presentation. That means we are developing our products not from scratch, so not based on a blank sheet of paper. So we are starting to develop always on reference, always based on previous product generations, based on predecessor systems. And of course, then we can, when we have the challenge to reduce the vehicle weight, we can change material. We can, of course, change the connections between our different components and parts. We also can, of course, optimize the shape, so the embodiment of different components. So, for example, to optimize via topology optimization. We can also go into more complicated ideas and conceptual parts like integrating functions, so to reduce the amount of components. Or if it's possible, we can also think about the requirements. Is it possible to reduce comfort? But of course, nowadays, most product development processes aim on more comfort, aim on more safety. So reducing requirements normally isn't possible within the projects we see. So here are the different lightweight design strategies, so I just want to link this with the different lightweight strategies as material, manufacturing, form, system, and conditional lightweight design strategy, which are, I think, more or less commonly known through literature. There are some other approaches, but I think most of us will agree that those are the possibilities we have in lightweight design. So we here at the IPAC, we focus, of course, on the one hand on those three lightweight design strategies, so material lightweight design, manufacturing, and form lightweight design. That means, of course, this is also how many corporates work. So they are structured also in different subsystems, and this is a typical task we also fulfill here at the IPAC, at the KIT. So we are trying to focus on a specific subsystem. So for example, a control arm in a suspension of a vehicle or a specific part of the chassis. And then we try to get as much out of it as possible. So we are trying to find the right material for the function. We try to find the right design for it. But this, of course, focuses only on material manufacturing and form lightweight design. So what are specific approaches we are using? So today, of course, fiber reinforced polymers, so in short FRPs, have a really growing market. We also could see this when we started with our first project about 10 years ago, where we started to develop methods and researched on methods how to include manufacturing process into a design process. So in this case here, we are including a mold filling simulation, form filling simulations into a topology optimization process in an iterative way. This is here shown by this picture on the top right side here. And by doing so, we are able to include the fiber directions we are having here. So we are using long fibers, so for example, carbon fibers or glass fibers here. And we are able to predict the material behavior within the optimization process. And this allows us to optimally use this material behavior for our dedicated function and to transfer our forces through our part later. Another example how we can include different processes, so different manufacturing processes into our design process is here shown for the selective laser melting process. I think most of you know the 3D printing process that is shown here. I just brought it to give you a short impulse on it. And of course, this material is printed within layers, of course, and also those layers later have an influence on the material behavior we can see. So of course, one might say you can print as slowly as possible and with high energy, then most of the layers cannot be seen later. But to be in a cost-driven process successful, you of course need to print very fast, and therefore you will have the influence of this material within your later structure. You can also see this here on the right-hand side. It's a CT scan of a SLM printed part here. And there we decided to have 3 different zones here. We have the inner volume, the outer contour, and the different printed layers that are shown on the right, on the left-hand side. And we are measuring the material behavior here together with a partner institute here at KIT. And then we are including this material behavior, which is laid or layout over our different structural parts within a topology optimization. This is shown here. This is the process for it. So we start with a normal CAD model. Then we transfer the process data. We map the process data of the SLM, so the selective laser melting process onto the part. And then we can do our topology optimization and get a new optimized design, which is optimum dedicated to the material behavior we have from this printing process. Another approach we're following here at the IPAC is the optimization of thin-walled structures. So we are introducing beads to the structures and increase the stiffness. And also there, if you think about using fiber reinforced polymers here, for example, but even using just steel, of course, there's an influence from the manufacturing process, and this also can be included into the bead optimization process, which is currently done within, I think, 2 or 3 projects like this time here at IPAC. As I mentioned, of course, those 3 different lightweight design strategies are necessary and important, but of course, there's also more, I think, and this more is to combine it on a cross subsystem approach so that we can include all the lightweight potential within projects which overcome those boundaries I mentioned before, so that we can find the overall system optimum and not just local optima as we do it in the approaches shown before. This is called concept lightweight design then here at the IPAC. And one of the approaches we are using here is the extended target weighing approach. And this extended target weighing approach is shown on the right side. I know this is too much information to fully understand it. What you need to understand, I think, is we start with a product generation we already have. Then we analyze our different function of this product generation. And also we analyze our efforts. So we include the mass, of course, in lightweight design of our product we are taking into account, but we are also analyzing its costs and its CO2 emissions within those projects. And this enables us to calculate the effort of one function, and then we can decide where is lightweight design necessary and useful, where it is also useful from an environmental point of view. And then we go through this complete process here and end with a new product generation in the end. So that's just in short what we do here. I brought 2 examples. So one of those examples is here the high voltage battery we optimized a couple of years ago. There we had to go to reduce the weight, of course, of this battery by 20%. Of course, we did it not just alone at our institute. We worked together in a bigger consortium here. But what you can see is that we have already in a really early phase of the product development process. So here in the concept phase, we can compare different concept solutions and decide based on weight and costs here in this example, which is the best solution in the end. The same had been done here for this high voltage battery. So it's a different car manufacturer, as you had seen before. There, we had been even more ambitious at this time. So we tried to reduce it by 25% in this project. This has been done completely by IPAC. I think around 6 or 7 years ago was one of my earliest projects here at KIT. And here we had also a part of a battery, so just the housing. And there we developed also an approach to analyze different functional areas with this approach. We developed different correction factors. And also here we came up with different possible solutions. So we started first with just conceptual drawings made by hand, and then had different solutions more detailed in CAD, and could decide what is possible towards the mass we need to reduce here. So then we had further projects in electrical energy storage systems where we tried to find new solutions also based on combining different methods. So like, for example, topology optimization together with a packaging algorithm that had been developed. So we started here with the initial design phase and developed a first concept design. And there we could have an easy ranking of different concept solutions. So where to apply how many cells, for example, in this energy storage system here. And we also could automatically evaluate how the later mass and how the structural behavior of this component will be. So this had been done, as you can see here, by topology optimization, which had been completely optimized. So we included our battery model, our design space into a complete analysis model. And then we had in the end different suggestions of our structure and could compare which is in aspect of lightweight design more suitable than others. Here are some more exemplary solutions to that. And to not exceed my time too much, I will leave it here and just motivate for just using the methodologies. You know, for example, to have a design approach, then go into CAD, then go into calculations or FEM models and try to find your best solution. It's not always the best process. Sometimes it makes also sense to introduce methods and tools like the topology optimization to really early parts in the product development process and try to find best concepts and compare different concepts as shown here. So to conclude my short introduction and how we see lightweight design, I want to motivate that it's important and conclude that it's important to think in product generations. So you have to use the information you have from predecessor systems. You have to find a way to manage your knowledge in a sufficient way to make your knowledge applicable to new solutions. This can be done by systematic views, by integrating material, computational methods, modern processes, and this leads in the end to the chance at least to exploit the full existing lightweight potential by a systematic approach, by a concept lightweight design approach. So thank you very much. I hope I didn't exceed my time too much, and I'm looking forward to the really interesting challenges, and first of all to the introduction of the NMWP, I think by you, Matthias, right?
No, it's by me. So thank you very much. Everything's fine. Thank you very much for your presentation. Okay, so then I will go on and we will have a short presentation about the cluster NMWP.NRW. Hold on a second. I have to share my screen. It's this one. Share. So the cluster NMWP.NRW. So first of all, about North Rhine-Westphalia, it's in Germany. It's classic. It's the land of which industry is focusing on materials. And we, as the cluster nano micromaterials photonics, materials is one very important part of this. First of all, I would like to give you a short introduction about key facts about the clusters in NRW. So what are clusters in NRW? Now, the state policy is promoting a sustainable industrial development and addressing the lead markets. Clusters are pivotal instrument for the state's strategy. So the clusters act as a link between science and industries and politics. We are identifying emerging technologies, and we promote innovation and visibility in 8 lead markets. Clusters are expected to develop cross-regional initiatives, both enterprises and universities, to increase the dynamics of innovation. And I think concerning the cluster nano micromaterials and photonics in North Rhine-Westphalia, there's one thing which should be mentioned. Most of the clusters are focusing on application fields, but we are focusing on technologies. We are focusing on key enabling technologies, and they are all cross-sectional. So what does this mean? In the end, nanotechnology, microsystems, advanced materials, photonics, and the latest technology we are focusing on is quantum technologies. They're focusing on nearly every lead market, such as automotive and aviation, but also for years focusing on lightweight construction. For example, quantum technologies, I think Markus already mentioned the simulation of materials, and this ICME, or maybe ICMME, integrated computational materials and manufacturing engineering. I think there, in this case, the quantum technologies will have a great impact in the future. So what do? We are addressing these societal challenges, and we are providing solutions based on key enabling technologies for nearly every industry, and also on lightweight construction. So I think we are a network, but we have very strong partners, from large enterprises, international enterprises, up down to hidden champions, small and medium enterprises, or even startups, institutes, and so on. And there's also an association, and here are some partners. We have about 100 members. And as you can see, there are international companies, also from the aerospace and the automotive industry, as well as service providers. So what do? We enable innovation everywhere. And how do we do this? And this fits perfectly to RIGHTWEIGHT. We do this by networking. So face-to-face events aren't possible due to Corona, may be possible in the future, but also online, like our meeting now. We are providing information via marketing, a known magazine, newsletter, and so on. But I think very interesting for the project RIGHTWEIGHT is we are focusing on project development. So we have the right partners, we can find the right partners, we can give supply of or consulting and funding schemes, we do project management, and also on a strategic level, processes with academia and industry. And we have a good communication with responsible ministries on federal, national, and also European level. So just to give a very short example, what is meant by this concerning to the activity of lightweight construction. For example, we have if you take a look at the economy, we have this raw materials, innovative new materials. We have Momentive, SMS Group, Covestro. So we have metals as well as polymers. We have composite materials and also functionalized materials. And then we have these semi-finished products, components, and post-processing, and also OEMs. So I think it's along the complete supply chain. There are several networks, and we have a very strong expertise in research in North Rhine-Westphalia. RWTH Aachen, I think it's one of the bigger universities. We have also smaller universities and also institutes, a lot of Fraunhofers which are involved into lightweight construction, like and So how can we be of service for you? Now you can benefit from our services. We have strategic consulting and support for setting up technology-driven corporations and businesses with partners in North Rhine-Westphalia. We have a strong network, so we can give advice in this. Also, we have a guidance. We have an overview about the North Rhine-Westphalia's economic and research landscape, so we can help you with this as well. Advice on specific NMWP related topics and possibility for grants also. And we have also a certain link to the policy community. So this is NMWP in a nutshell. And Markus said in his presentation, lightweight influences all sectors of the emerging, of the engineering and design. And I think I can conclude with the key enabling technologies, nano, micro, materials, and photonics, and also quantum technologies have a strong influence on every industry and also on every part of lightweight constructions. And with this, I would like to end, because lightweight is always or has already been presented. And then I would go back to the last presentation, and then we can go on with the challenges we have. So give me 1 second, please. Start the presentation. Okay. So now I think we can go on. I think, Matthias, do you want to start with the challenges we would introduce, or who wants to start?
Yes, I would go through the first set and then hand over to our partners.
Okay, so perfect. So then the floor is yours.
Yeah, then a quick hi and welcome everybody from my side. I'm Matthias Grosch, working at NMWP, and I want to present you some of the challenges of the RIGHTWEIGHT project. And so the just brief introduction, challenges are split into 5 overall topics. So the first topic is materials, supplies, and development. Here are presented all of those challenges that fit into this topic. And on the next slide is the challenge I want to talk about. First challenge I want to present today. If we could, next slide, please. Yes, exactly. That would be challenge number 9, which is cryogenic material applications. As we know, the more and more alternative more and more alternative fuel usage is promoted in aerospace. I mean, also it's already used in space applications. There's the need for new materials for cryogenic tanks. And the scope of the challenge here is that there will be a resin system with it's necessary with matching thermoset, thermoplastics, and definitely a high temperature and chemical stability. Here on the right, maybe some recognize it. This bluish color, it's liquid oxygen. That's pretty cold and it's also pretty reactive. So it has some high obstacles that need to be overcome for the material. The current production technologies are filament winding or automated fiber placement, automatic tape laying, or laser-assisted tape laying. All of them have some benefits and some drawbacks. For example, the 2 blocks here shown in the middle, the things that this resin is either has a high permeability, which is not so beneficial for storing the slowly turning to gas material fuel inside, while the low permeability is much better. Also for the idea of cryogenic application, of course, because temperature the temperature change will decrease if it's low permeability. So the challenge objectives would be finding the best compromise between cost saving, mass saving, and then performance. So it should be lightweight, but of course it needs to really work as a good cryogenic tank material. It would be nice to develop a breakthrough technology for the cryogenic tank application. And a scope of this challenge currently, it would be just the demonstration of material and technology a maturity on a small scale prototype, so that on later steps, large scale application can be done. Yep. Then the next set of topics or challenge topics, next slide, please, is characterization and modeling. As we saw in the EPAC presentation already, the modeling before building the part is very important, and can always improve the lightweight properties of the material, the component. So on the next slide, here we have something, it's not exactly automotive, but it's basically the same area. We have the agricultural machines, and there the challenge number 13 is the topology optimization on shell elements to strategically cut out material from metal sheets. So this cover metal sheets are kind of, they exist, but they should be reduced in terms of weight. So a redesign of the metal sheets is necessary. And here the challenge objective would be to optimize the topology-based shell element and keep the stability but reduce weight. Yes. Next slide, please. Exactly. This one is design space optimization, so reducing connection joints in large assemblies. So often there is it's happening in machinery assembly that this certain design space is given. So like on the left side, it's in the first design, it's known, okay, we need these joints covering this area, but the overall design is not optimized for lightweight. So there would be the need of topology optimization in the given design space, and maybe even this is open to discuss in the challenge with the challenge owner, the optimization of joints in terms of amount, position, and also of course weight. Next slide, please. Yes, the third topic of challenges is about design and smart functions. It's more and more common that the material is not just a simple material, but of course it has more elevated functions. On the next slide, as people who are familiar with aerospace, they are the European Technical Standard, ETSO. So the European Technical Standard orders, so that components that will be developed need to be certified. And here the target is to develop an all-electric composite aircraft, whereas as in open discussion with the challenge owner, these advanced components shall be designed and cost-effective solutions shall be proposed. So there are here different possible objectives. So not all will be done in one challenge, but it's open to discussion. If you apply, you can get in contact with the challenge owner and do something like an effective aircraft sign that thanks to advanced composites. You can do some system integration, develop a health monitoring system for the composite and the overall system. And finally, that should lead to the transition of an all-electric aircraft that is newly designed and highly lightweight. On the next slide, yes, there we are on topic number 4, the manufacturing and assembly. As we had before, the automotive has high number production, but aerospace sometimes is let's say slower or more special in assembly and then manufacturing. So they should learn from each other. And that's what we have in the next slide, please, which is challenge number 11, high performance lightweight materials for aerostructures. So there are material and building components that are already present or in use, but the topology optimization is necessary. It would be, or is highly desired, that the interchangeability with existing parts is given. And the idea would be either use newer composite materials instead of the currently used steel parts, and or combined with 3D metallic printing to allow even better topologies. So this is basically also challenge objective. So latest 3D printed metallic structures and a cooperation to finalize a technology partnership to then develop a sample or prototype is desired. On the next challenge, it's the out of autoclave panels. So autoclave is a synthetic technique that takes quite a lot of time, but gives very nice results. And so nowadays, many thermoplastic composites are manufactured in autoclave to consolidate the properties. But autoclave takes a lot of time. So there are the state-of-the-art data here, and if somebody has a nice idea, the challenge objectives would be then to find a affordable production method with a shorter cycle time, then determine the manufacturing costs respectively, and to produce then one demonstrator so that can be thoroughly tested afterwards. On the fifth topic is recycling, as it's not just about producing something lightweight that is of very unrecyclable or not so environmental friendly material. Recycling becomes ever more important. And here we have on the next slide the repair of composite RTM parts. So most often a composite material, if damaged, has to be replaced completely because of the nature of the composite. But this is very, very cost efficient, costly, and not cost efficient. So of course, as everybody can imagine, there's the threat of danger of damage through small objects, especially in aerospace. And it would be nice to find an in-field solution without the necessity to disassemble the plane, for example. And this would of course extend the life cycle of the part repaired, but overall also of the whole system, of course. Challenge applicants should present and validate a composite repair methodology towards an Aero Tier 1 supplier. It would be necessary to present a damage assessment tool with non-destructive technologies, and of course a damage removal or patching of damaged composite materials, and methodology for quality assessment after the composite part. Okay, yes, and I came here this morning by bus, so I'm pretty familiar with this one. Improved recyclability and carbon footprint of thermoplastic extruded and pultruded interior of buses. So of course, there's a lot of plastics structuring around, and there a lightweight, cost-effective, and low carbon footprint solution is desired. So the state of the art, once you're in a bus, a lot of coverage material is some polymer. The roof ducts, for example, are made from continuous 2D profiles, and the 3D hedges for warm summer days. Currently, they have a high weight because they have a certain stiffness to achieve, and they are from materials that have a low recyclability. When thinking about that, the challenge owner said the ballpark volumes are roughly 75 to 100 kilometer per year. It's a flowing process, and for 3D hedges, it's 75 to 100,000 parts per year. So it's quite a volume. So the objectives would, of course, be to evaluate the design, topology optimization, structure optimization, but material and the mechanical properties, and of course, find a new material class with a lower carbon footprint, if possible. Then present a feasible demonstrator, or maybe already a small series production to verificate the project, and then supply the part for series production. On the next slide. I think,
well, this is already it. So
then we would hand over before we explain infrastructure and
Okay, so we will proceed with the next challenges. So we will not present it based on our different slides. We will start by also introducing to you our homepage of the RIGHTWEIGHT project. So this is the central site. You already had seen that there are different cross-cutting areas, which had been also introduced already by Matthias in his presentation. And what we are now going through are the different challenges here. So the cross-cutting areas will also be highlighted in the different challenges. As you can see here, this is the address of the homepage. I will also share the link with you via the chat here. And if you go here on to the challenges, you can see that there is a list of different challenges proposed by those, but not only those OEMs and tier 1 suppliers. And as you can see, there's a list of many challenges already out there, and more will come, of course, in the future. So I will start with challenge 1 here on the homepage, which is the challenge of novel interior cabin design for greenest aircraft. So the greenest aircraft concept here is the idea to have a zero emission aircraft in the future. And this changes not just, of course, the interior design, but it changes the interior design because of the changes in the power and the propulsion and energy concept of the next generation aircraft. So that means for the cabin design, we need to find new ideas for the design of the interior. We need to have a new styling. We need to develop new surfaces, which are also easy to clean and sanitize. And of course, this has to be also included with touchless solutions for passengers and crew members. Another part of this challenge is also to develop new materials and processes for environmentally friendly lightweight design solutions, so that we have it based on 100% recyclable resources, and that, of course, all of the components can again later be recycled again. Furthermore, of course, we need more affordable technologies for the material treatments and processes. So we need to have mainly promote recycled carbon fibers in sheet molding compounds for semi-structural applications. Then we have to find solutions here in this challenge also for the automation of the manufacturing process. That means Industry 4.0 concepts need to be included. Also, one of the topics that might be a part of the solution is to use augmented reality techniques here. And last but not least, the maintenance of these new structures and also of the complete structure is necessary. Also, the data can and should be used from the manufacturing and supply chain we have. And this will also include things like 3D printing and additive manufacturing here. So the main section of application of this challenge number 1 is, of course, aeronautics, and cross-cutting topics are almost everyone you had seen before on the first web page I showed to you. So we have material and supply development, excuse me, design and smart functions, manufacturing assembly, as well as recycling. So here are some more information about the scope. As I mentioned before, we want to come here in this challenge, or the challenge giver wants to go into a circular and green economy by also reducing, of course, the CO2 footprint of the aircraft and the aircraft design. So again, the challenge objectives here are to extend the usage of recyclable material, so that there in the end are 70 up to 100% recyclable and made out of recyclable material. The fuel consumption within the overall weight reduction is between 8 and 12%, which should be decreased. And of course, the RC costs should be at least reduced by 5%. Okay, that's it about challenge number 1. Then we go to challenge 2, which will be presented by my colleague, Patrick Haberkamp.
Thank you for the introduction. Yes, so the second challenge is on the topic of cost-effective components for aero and auto transportation. But with the small change that we need also the flame properties and low impact features. So as often used in today's aircraft or automotive sectors, also here the use of composite and polymeric materials is the central part of this challenge. So additionally, we need to take into account the process reliability and also cost effectiveness, as well as the environmental aspect of the materials. Since in this challenge, the challenge owner likes to develop aircraft interior components as well as autobus secondary components, we also need to fulfill the requirements for structure, for the flame resistance, which is especially for aircraft interiors very important, as well as smoke behavior. We need to find new solutions for materials that can be applied here. So the main section of the application is, as mentioned, the aerospace section as well as the automotive section, and the main cross-cutting topics is, as the challenge before, design and smart functions, material supply and development, manufacturing and assembly, as well as recycling. So you see there's a wide range of possible solutions here. The scope of the challenge, as I mentioned, is the use of recycling of circular economic materials for aircraft interiors, as well as autobus secondary structures that also give a high performance. And the objective is the development of effective composite airframe and components, and the use of low impact composites. So that's it for challenge number 2.
Thank you very much, Patrick. So I will take over challenge number 6. So here the idea is to develop solutions for automotive large body parts in 3D printed composites. So here the challenge is to include additive manufacturing processes into a broader application. So the idea here is also to have high performance composite materials combined with an optimized design to reduce the weight by including 3D printing processes for car parts. So the company here is CRF, which also is stated here, and they want especially evaluate and assess the new technological solutions here. The main sections of applications are automotive, and maybe they think about also applying it to other sectors like maritime, railway, maybe even aircraft. And the main cross-cutting topics here are design and smart functions, as well as manufacturing and assembly. So the scope, as mentioned before, is the use of 3D printing technologies to replace large car parts, so not just smaller components as it had been done before. So they're thinking about parts like spoilers, fenders, or the pillar, and also to think about how they can use it to personalize the cars they or the components they deliver for the cars. So they think about special models, sport versions, without any additional or without huge costs for new toolings. Furthermore, they want to use structural composites to reach cost-effective solutions with expected performances at lower weight. So they think about, of course, also fiber reinforced polymers in the 3D printing process here, for example, and also necessary part redesign, which is based on the new technology for the manufacturing process. So what are the challenge objectives? In a nutshell, so they want to reduce the weight by 30% compared to steel parts, or by at least 10% compared to plastic parts, with the boundary conditions that they will have more than 5,000 parts produced per year. So this should be also possible when you apply for this challenge here. Then I hand it over back to Patrick again with challenge number 7.
Yes, so challenge number 7 is about fostering biocomposite structural parts in automotive usages. So the idea here is the use of biomaterials, for example, in natural materials for fibers, as well as biopolymers for a biocomposite combination that also give a high mechanical high mechanical properties, so they can be used in structural applications, for example, body panels or cross members. And here the idea is to develop new material combinations, and the scope here is especially the development of this material and not the parts. So the scope is the use of biomaterials for the production of car parts that also need to be secure and stable. So we need to have components or the materials that can be gained or be available in a large amount, since we still need to produce large amounts of cars. The long-term properties of these components also need to be comparable to durable parts, for example, steel components, because it would be not really beneficial if we'd have components that need to be replaced after every year. So the long-term properties also need to be reliable. And the last aspect is the guaranteed recyclability at the end of the life of the vehicle. So the challenge objectives of this challenge is the development of cost-effective biocomposites to reach the target of green content in automobiles up to 50%. That the materials also is available in the supply chain and not just a rare component. And also we need to have the materials to fulfill the mechanical performances that is necessary in today's cars.
Thank you, Patrick. So I will proceed with challenge number 10. So here the idea is to have a cost-effective lightweight design and a toolless manufacturing for an air intake. So we have here a very special component, what this challenge is all about. So the idea to have this intake duct of the ECS application. So the ECS is the environment control system, for those of you who might not know that. So I will directly go down here to show you this component. So this here is the Ecs Air Intake. It's today made out of thin-walled steel plates. You can see there are at least 2 different tools necessary to manufacture it. There's maybe also a welding or riveting process included to manufacture this part. So that means that this design is really hard to change, or it's not to change without affecting the tools you need for it. So the scope of the challenge is to create demonstrators, so to have an initial part where alternative material solutions are implemented, ongoing, of course, with a different manufacturing process, which will lead to a more cost-effective lightweight design here. Furthermore, this should be also tested statistically, so it's not just about the design process, it's also about the validation process here in this challenge, so that in the end there are new materials and processes identified that can bring up significant weight and cost savings for this component with a similar complex shape. So what is the scope? Processes that can be used for the parts with complex shapes are monolithic as possible. So here failure is of course a big issue in this field of application. Then the search for lower cost material to qualify and search for legal ones to be used for a possible product certification. And as mentioned before, the structural testing campaign should also be provided by applying to this challenge. So again, the challenge objectives here to realize the demonstrator in alternative material and process for this air intake duct for the ECS. And this should be based on the reference you had been seen before here shown on this challenge. And then the solution should come up with a weight reduction by 50 up to 60%, while reducing the cost by 10 to 15%, and including a method to qualify a material and process to be able to apply it to similar items. And furthermore, you should be able to come up within a supply chain which is able to supply this new part for the aeronautical branch here. So then I give it back to Patrick again.
Yes.
Able to change the slide. Challenge number 12.
Yes, so challenge number 12 is quite a specific challenge. It is on the guidance blade of agricultural machines that is commonly used with the dimensions of about 2.5 meters to 1.5 meters. And it's used to guide crops over. And today, this blade is usually made out of steel. And so it takes a large amount of weight of the device. So the challenge objective here is to identify a lightweight material to decrease the weight of the component as well of the system itself in total. The clue of this challenge is also that we have a special requirement since this blade is under an abrasive load of the crops that are gliding over this blade. And so we need to have these special requirements for the materials. And this is the scope of challenge number 12.
Okay, thank you, Patrick. So challenge number 24 now is also again in the field of buses. We had this one before. So here the idea is to develop a new crash floor structure for buses. So the idea is to increase the safety of a city bus. And the idea is, or the initial state here is, that most city buses are not that crash safe, especially for the driver. There are almost none regulations, as you might know it from the automotive industry, on the well-known crash tests. So here seems to be a lot to be done to increase the safety of the driver. So as the challenge stated above, this should be done by increasing the safety by developing a new floor of the bus. So most of the structural parts and of the structural stiffness is provided by the floor of the bus. And so there also can new solutions be found. So again, automotive or also other sectors are possible. Here it's characterization, modeling, design, and smart function, as well as manufacturing and assembly. And the idea is to improve the crash behavior of the bus with maintaining the current weight and cost of it. And there should be no added weight and cost if possible. You can see here one example what happens or how it can look like if it goes wrong, if there is a crash. And we are talking about here the bus floor structure, which is responsible for the main stiffness of this vehicle. And new solutions should focus on this floor structure here. So once again, the challenge objectives are weight and cost neutral redesign of the front floor section. So this is the part here. can see here, which allows to improve the crash behavior. There should be new additional crash features be designed to improve safety, and it's also impossible to have a modular design because it's manufactured modularly. Here are different suppliers involved in this process. So then for our last challenge, again, Patrick.
Yes, so the purpose of the challenge number 25 is the development of innovative aluminum lightweight components for the green road mobility. So the challenge is with the title Aluminize the World, and it is to enable sustainable and innovative solutions for the automotive industry. The target is to reduce CO2 emissions and support the green mobility. We want to develop innovative lightweight components on the base of aluminum, and also develop innovative cryogenic tanks for long-haul transport applications to store liquid hydrogen. So, as can be seen, the main section is the automotive section. The cross-cutting topics are the design and smart functions, characterization and modeling, as well as manufacturing and assembly. The scope of the challenge is to help the challenge owner to change over from a tier 1 fuel tank supplier to a manufacturer of components in total for sustainable mobility. And here the scope is pretty wide, so it can be from long-haul transportation solutions as well as last-mile transport solutions. And important here is the idea generation and knowledge of typical market issues that need to be extended for the challenge owner. So here we see some examples of lightweight aluminum components. For example, here cap brackets, rear suspensions, or brackets for front underarm protection. If we go further, we see, for example, here aluminum parts in a car underbody or armrests for aircraft seats that are produced from aluminum, and show the possibilities that are available to develop new components and help the challenge owner with new ideas. Also here, a very current challenge is the use of aluminum for battery modules as a box, or the cryogenic hydrogen tank. So the challenge objectives are the production of aluminum battery boxes with a high range, so from 1,000 to 200,000 parts per year, and the challenge owner likes to have a cooperation with a battery cell production company, as well as a sustainable mobility customer. The second objective is the development of lightweight aluminum components with the production system of reo-casting, also with the range that is quite wide, so from 15,000 to 150,000 components per year. Also, the third objective is to develop new ideas for aluminum components and to establish a cooperation with sustainable mobility partners, and provide the production processes and services. So that's it for challenge number 25.
Okay, thank you very much, Patrick. So I can hand over back to Hendrik.
Yes, thank you very much. And I would hand over the screen to Gabriel from Flanders Make, so he can present the last not least, challenges, and we can have the questions afterwards, I would suggest. So, Gabriel, the floor is yours. We can't hear you.
Can you hear me now?
Yeah, now we can hear you. Perfect.
Okay, thank you. So those are the challenges that we have. So I will not enter in all details, but my objective today is just give you provide you an overview of some of the challenges that are coming from the companies in Belgium. So something that we have to know that we have in the first material supplies and development, something that we quite identify is that the partners are interested in biomaterials. So the challenge that I want to propose today is the one that is the challenge number 15. And the objective of this challenge is to create composites using biomaterials for the aircrafts. So the objective is to develop parts from aircrafts using biomaterials that are compatible with the aerospace standards. So this is the first challenge. So if you have more interested in this challenge, you can go and find more information here in our own page. But yeah, it's if you are involved in biomaterials and the composites, you should contact us. The second one is also for another company in Belgium. They are interested in the characterization and modeling. So we have to point out that in Flanders Make, we have some experience with the modeling and characterization of components. So what we want to do here is that we want to optimize the geometry of some parts of for these tractors. And the optimization is not just in the shape, but also in the fiber orientation. So we want to take fibers and fiber orientation within the optimization process. So if you have some experience with that, we are looking for that. The company here, they didn't mention their name, but they are eager they need this kind of solutions. And if you have the possibility to provide this kind of solutions, please contact us and we will put you in contact with the company. But yeah, it's mainly topology optimization and orientation of the fibers. There are other things, but topology optimization, the assembly and design for assembly and design for manufacturing is something that we are interested and in general in the challenges. This one is maybe the most representative challenge that we want to present today. Then design for smart functions. So we are also interested in the design of the design process. So here we are interested in designing the back seat of a car. We want to reduce the weight by 30%. To do that, we are aiming to change some of the components from metal to plastic or composites, so we can improve the efficiency of those cars. So as you saw, this project is mainly to reduce the weight. And to do that, we want to not just simplify the things, but we want to do a finite element analysis to analyze from the early design processes how, of course, this can be applied to other parts of the vehicle, but in this case, the partner is interested in the rear seat. Another thing, this is from an aerospace company in Belgium. They are forming aluminum materials, so they are already working on forming. However, one of the problems that they have now is that they spent too much time in their processes. What we would like is to have a better forming processes for aluminum. So this is still you have all the information about this in the challenge 21. But our idea is that we want to use vacuum to do the forming of the aluminum parts in a faster and more efficient way. So this is another challenge that we have. Last but not least is the recycling. So we are also looking for challenges in the recycling part. As you know, so sometimes the composites are not so easy to recycle. This challenge is a little bit more generic. It's not just connected to one company, but it's in general one company who proposed, but it's a little bit generic. I think it's interesting for more people. But the idea here is to find, identify a way to have a better recyclability of the products. So thinking the post customer of the product. So those are the main highlights that we want to show today. So as a reminder, we are biomaterials is something that is really interesting for us. Then we are interested in topology optimization, but also that take into account all the composites, the composites and the fibers that we are using in the composites. So is to really go deeper than just the shape of the parts. How we can replace metallic parts by using composites and lightweight solutions. Finally, to develop a smart processes to do the folding of lightweight solutions, so like how we can work with aluminum in a better way, or even with composites. And finally, the recyclability of those products, because we don't gain a lot doing lightweight products if they are not recycled. So those are the 5 challenges that I want to present today. It's quite summarized, I didn't enter in all the details, but I think that can provide you an idea of where we want to go here with the companies in Belgium.
Okay, thank you very much for your presentation. And now I would like to ask you, are there any questions until now for the challenges? I can share my screen again, and then I can say, wait, here are the challenges. So if you already have any questions which we can discuss right now, just raise your hand. Wait, I need the overview of the participants. Okay, raise your hand or put your challenge into the text, into the chat, or maybe I think you can just activate your microphone, and I think we will be happy to give you as much answers as possible. I also put the link of the challenges website into the chat. Peter Walker from Otto Fuchs KG. So the floor is yours.
Hi, yes. Firstly, thank you very much for an interesting workshop so far. It's been very informative. I actually have 2 hats on today. One in my role as innovation manager at Otto Fuchs KG, and the other as a representative for a small startup based in the UK. And so I have a few questions regarding some of the challenges. I guess that the first one is from my role at Otto Fuchs, which is that we are obviously not an SME. We are a much bigger company. And one question I had was, is it possible to submit new challenges to this program as a tier 1 supplier?
Yes, we would be happy. So get into contact with us, and then yes, because I would explain this again later on, but there are 2 rounds of challenges, and this is just the first round. So we can provide new challenges. We would be happy to provide new challenges also from North Rhine-Westphalia, like Otto Fuchs, in the second round. So great idea.
That would be fantastic. So I think internally we would also have to do a little bit of a ideation phase and things like this to target a really good challenge. But so far I can see from the challenges that there are some crossovers as well. It's I mean, I also understand that from the rules of the competition, so to say, there will be about 50 SMEs in total which are selected for these challenges. And I guess there are more challenges than there are SMEs that apply.
Yes, I think so, possibly. But hopefully, at least you would get into contact with people who can provide solutions. So I think there are, on the one hand, yes, we focus on giving the grants to further develop the innovations. But on the other hand, we really would hope to provide you some context with solution providers, even if they are not selected to be granted. So I think you could also, at least you can benefit by this.
Yeah. No, well, I think I know the main aim of RIGHTWEIGHT is to support SMEs, but there were some challenges in there which I thought, hey, as an innovation manager here at Fuchs, this is a really interesting topic for me, and topics that I'm working on right now. And yeah. Is there possibilities for a company like, obviously we would not get the funding, we would not get funding for this, but is there possibilities to be in contact with the challenge providers to talk about these topics?
Yeah, I think so. I think this should be possible, but to be sure, I would ask the consortium if it was really possible. But I think in the end, for us, it's important to link the industries and service providers with people who have challenges. So I think so. In the end, we should talk about this, definitely.
Yeah. Okay. Yeah, this would be fantastic from my side. Like I said, there were one or two challenges where I thought, hey, I have a project that literally is solving this directly.
Okay.
It would be great if we could. Yeah.
Okay. And then your second part, I think this is focusing on the challenges, and you have questions for this, so maybe we can help you with this as well.
Sure. So yeah, I'm working with a small startup based in the UK. And this is then a general question straight away: is a British-based SME eligible for this funding? Because it is European funding, and yeah, with Brexit, it's not so easy.
Okay, in this case, I'm not sure if I can provide an answer, but maybe Markus, Patrick, Matthias, do you have any further ideas, more into detail into this project, than more knowledge than I have?
So it of course it falls into the area. I am not sure of the latest regulation, but so far it was possible.
That's also what I think. So it should be possible. So we should look it up maybe, but I think it should be possible. I totally agree, Matthias.
Okay. Yeah, from what I have read so far, nothing kind of closes it out, but I do know that the EU regulations changed for what type of funding is allowed for British companies now.
Exactly.
Okay. Okay, and perhaps one other thing is the application looks as though each SME applies on his own for each challenge. Is it possible to almost have a consortium? So I know the SME that I'm working with, they focus on recycling of composite components. But they don't do anything. They would need support from someone else then to turn these composite fibers that have been recycled into a preform or into a textile. And my question would be, is it possible for the two SMEs to work together and supply a joint application, or can only one apply at any time?
So yes, maybe I answer this one. This is absolutely possible, and this is also what we want, of course. The only question then later, of course, will be if you apply together on this challenge, who receives the funding. So if you will receive the funding, this will be something you should discuss about in the consortium. Of course, you will need to also have a consortium agreement, as we do have it in this project as well. But of course, collaborating is one of the things we want to emphasize, and we want to foster here, of course.
And is that also part of the the role of NMWP or KIT to also put companies in touch with each other, to put, I guess you will see all the applications and you'll see which SMEs have which strengths, and then maybe you can say, hey, you know, some of them aren't so strong, but maybe it goes really well with X, Y, and Z. Will that also happen, or is it more dependent on the SMEs to build the relationships first?
So both ways are possible. So of course, in the consortium, we're also working on putting things together, discussing who might collaborate with whom. So both are possible. If you want to come up with a partner, you can do this, but we will also try to bring different SMEs together with the OEMs, of course, to perform challenges all together if this makes sense from our point of view. Yes.
Yes, I think, yes, networking, one short remark, networking is also a very important part of this project, and as well, I just mentioned it, but we have a digital networking solution, the NMWP portal, and we would like to invite every participant to register to this. It's free of charge, and in this we can we have a map and you can screen other companies and get into contact. So I think, yes, networking and getting into contact with other yes, challenge givers and also solution providers is definitely one of our goals. Yes.
And perhaps I have one last question, which is, can an SME apply for more than one challenge?
Yes.
Yes. But they will not get more than one set of funding, right?
I think it depends on the applications.
Okay.
I don't know. Well, I'm not sure, but I think if you apply to different challenges and you have very great solutions, I think it's a big question. You shouldn't gain every single funding, I think. But if you have a perfect solution for 2 challenges, maybe it could work. But
okay.
yes, it would be nice if we would have a certain scope and a bandwidth of companies which we support. Yes, but let's try it.
Okay, excellent.
Okay, are there further questions? Okay, if not right now, we will have a business lunch later on, so there you can network a little bit more. So I think I have just some more slides I would show to you, because we told in the beginning, we told about the infrastructure and about, for example, the field labs and the funding scheme. And I would just provide just a few more details and informations about this. Wouldn't take so long. So what are field labs? Field labs like Flanders Make. We had Gabriel presenting some of the challenges. They are thematic environments where new technological setups will be tested and replicated. And so we have these champions which provide industrial challenges. We have these field labs. And now we have the SMEs with the low TRL solutions. And within the field labs, we would like to support you to reach TRL 7 solutions. So these are the field labs. So if you apply for one of the challenges, it would be as follows. The challenges are presented by RIGHTWEIGHT champions. Just in this case, not by the champions themselves, but by the partners. Then the application is open. As again said, we have 2 application phases. One is running, but we have a second call for challenges, and then we will have these national workshops like this one. And as soon as the application phase is closed, we will evaluate the results, and then you can get a voucher scheme support. The application is now open. The application period, it started in May. It goes up to October. And here you can see the link of the application form. So, but don't mind. I think the application, let me see, you the link, whatever challenge is interesting for you, you will have the link beneath of every challenge, so you will find it easily, I think. And now, what happens next? There are two different types, two different ways, I think in the end, three different ways, but the best solutions provided are these trailblazer SMEs. So these they will get a voucher about over 45,000 euros, and there you can get services for this in these field labs concerning design, modeling, simulation, automation, testing, and so on. Also IPR, business planning, so also some advisors, and now these trailblazers should have an incubation up to TRL 7, and in the end they will have, hopefully they will have a route to market strategy and an investment plan. And then we have those 30 follower SMEs. They will get a voucher with 6,500 euros for the same type of services, and they will hopefully get an improvement of the TRL of the solution and a plan how to reach the TRL 7. So these are the ways you can benefit, and as already mentioned, I think in the end this is also a networking project. So if you won't become a trailblazer or a follower SMEs, I think in the end you hopefully will get at least some new contacts, and then you can find other ways to lift your innovation. Also, as already mentioned, we have, if you take a look at the timeline, we have the first call for applications, and we will have a second call starting in January. So we are still looking for new challenges. So you can get into contact with Markus and Patrick from the KIT, EPAC, or with us from NMWP.NW. And we will collect the challenges until June. I think we're still open for challenges, aren't we?
Yeah, this slide is a little outdated.
Okay, because June. Okay, so so if you have an interesting challenge, please feel free to contact us. I think this is a very good good possibility to find new solutions, and this is how to apply. As we already posted several times into the chat, we have this beautiful RIGHTWEIGHT website. You can find, this is also an old screenshot, you can find the challenges, you can find the application form, FAQs, you can find contact informations. So everything what is important, you can find it on this website. So these are the last few words I would like to give to you about the project. So I think now I'm done with this. And if you don't have any further questions, I can take a look. I posted the link for the Wonder Room at the beginning of the meeting. I copy it and posted one more. Did you already do this, Matthias?
No. Just posted it again.
Okay. So now I would like to invite you to change. Just click on this link. It's a solution called Wonder. It's GDPR conform, and there you have the possibility to do some networking, to get into contact with other participants and discuss a little bit. The room won't close later on, so you can still meet as long as you want. And I hope that you can get some further information, that you can drop some questions and also get into contact with new persons. So I hope we see you soon in our Wonder Room. So thank you very much for your participation, and we will meet in Wonder in now. Yes, we will meet now. So